Today's lesson is a continuation of the 2.1 note. So far we've talked about midpoints and how to calculate the midpoint of a line segment. And we've also talked about a median and what that is in a triangle. And so we've talked about how to calculate the equation of a median. And now we're going to look at the equation of a different type of line. It's called a right bisector. Now a right bisector is also known as a perpendicular bisector. So we'll write that down real quick over here. It's a perpendicular bisector because perpendicular lines are lines that intersect at a right angle. So they're the same thing. Perpendicular bisectors are the same as right bisectors. A right or a perpendicular bisector is a line that goes through an existing line segment. So let's draw a line segment here. We'll give a quick example. If this is our existing line segment from A to B, a right bisector would be a line that goes through this line segment. It goes through it and cuts it in half, so right at the midpoint is where it would intersect, and it intersects at a right angle. So this line here, that is what's called a right or a perpendicular bisector. That's the sign for perpendicular, that upside down, the upside down T there. Okay, so that line's a right bisector. It passes through the midpoint of the line segment and it intersects at a right angle. So in our note here it says it's the line that passes through the midpoint of the line segment and intersects it at a right or a 90-degree angle. Something that's special about this type of a line, about a right bisector, is that any point along that line, so whether I'm sitting up here or down here, any point on that line will be the same distance from the end points A and B. So if I were to throw a little point up there, that point, because it's on the right bisector, this distance here will be the same as this distance over there. So it's just a characteristic of a right bisector is that any point is equidistant or equally distant from the end points of the line segment. So we're going to move this up and we're going to look at the example on the page. It says two schools are located at the points -1, 4 and 7, -2 on a town map. So whenever we have a question, we're always going to sketch an example so that we can check our answers and make sure that they make sense. I'm going to do the best I can with my sketching here, although it's pretty difficult without a ruler to draw some accurate sketches, but we'll see how we can do. We have endpoints -1, 4. And we'll make sure we mark them with their letters and with the coordinates, and 7, -2, approximately there on our grid. Now I've drawn that line segment there the best I can. I've got no ruler on this app, but we're going to do the best we can with what we have. So you're going to use your ruler and you're going to connect those two endpoints to form the line segment, and then we're going to try to sketch our perpendicular bisector. It says the school board is planning a new sports complex to be used by both schools. The board wants to find a location that's equidistant, or that's the same distance from the two schools. So any point on a perpendicular bisector would actually be equidistant from the two endpoints. That's one of the characteristics of the perpendicular bisector. So we're going to try to determine the equation of the right bisector of the line segment PQ to represent all possible locations for the sports complex. So when we're going to sketch our right bisector, we have to find first the midpoint of PQ. Now you're going to look on your graph and you're just going to approximate where it would be. It helps sometimes to kind of rotate your page so that the line segment is horizontal from your viewpoint, so it's easier to see where the middle is. But I'm going to guess the middle would probably be approximately right there. And we'll see when we actually calculate it if that is in fact the midpoint. So we're drawing a line segment that goes through the midpoint of that line, and we have to draw that line segment perpendicular to the existing one. Now, sometimes it helps to take the corner of a piece of paper or something that has a right edge and to line it up right here. So if you line up the corner of a piece of paper or the corner of your ruler or some kind of a right edge with the line segment that's drawn on either side, it'll help you to draw a perpendicular line through that. Okay, so once you've drawn your perpendicular line segment, approximately where it should be, make sure that your line that you've drawn is hitting the line segment originally at a right angle, and actually show that in your diagram to show that you're thinking that it's a right angle, that you're conscious of that decision. The next step is we have to figure out what we need to get the equation of a line. Now remember, to find any equation, we need two things. We need a slope and we need a point on the line. So when you think about this new red perpendicular bisector on the picture, you would have to figure out a slope and a point that it goes through. We can start by figuring out either the slope or the point. It doesn't really matter which one goes first. Now on this page, the midpoint comes after the slope. Step 3 was the midpoint and step 2 was the slope, but it doesn't matter what order you really do it in. When you're figuring out the slope of this perpendicular bisector, you know that it is meeting that line segment PQ at a right angle. So it should have a slope that's perpendicular to the slope of PQ. So the first step is finding the slope of the original line to get the perpendicular slope. We're going to make sure we use our proper notation for this. Our slope of PQ is y2 minus y1 over x2 minus x1. So negative 6 over 8, which reduces to negative 3 over 4. That's the slope of the original line segment PQ. Now to figure out our perpendicular slope then, we're just going to take the negative reciprocal. So we're going to flip the fraction and change the sign to positive. Remember, these are negative reciprocals. Now in any question we do this entire unit, after every single step, we really should check the diagram and see if it's accurate. We should see if the slope that we got is the right slope. So we've calculated that the perpendicular slope is 4 over 3. That means that perpendicular red line on our picture should go up 4 over 3 on the graph. Let's see if it does. 2 points where it goes through the crisscross of the grid or through the corners of the grid boxes are our midpoint right there, and also that which would seem to be a y-intercept. From here to here, it goes up 4 over 3, up 4 over 3. So it looks like our calculation of our perpendicular slope is correct. Make sure that you check your answers against the sketch. Every single answer, every single step of the way, very, very important. So we have a slope of this new perpendicular or right bisector. Next, we have to include a point, because for the equation of a line, we need a slope and a point. When we look at our diagram, we can see that the only point that that red perpendicular bisector, or our right bisector, goes through is the midpoint of PQ. So the next step would be to calculate the midpoint of that line segment. So let's calculate the midpoint of PQ. Capital M is used for midpoint. Some people will write midpoint of PQ like that, and some people will write the coordinates of the midpoint M, X, comma, Y. I think this one's most commonly seen, but it's a personal preference. I don't mind if you do either. So we're going to calculate the midpoint by taking the coordinates of P and Q and finding the average of their X and Y values. So we use big brackets, and the average X value would take the two X coordinates and add them and divide by 2. And the average Y value, likewise, would take the two Y coordinates and divide by 2 after you've added them. So this is the average X and the average Y. Negative 1 plus 7 is 6 over 2. Don't forget your big brackets. And 4 minus 2 is 2 over 2. So we have a midpoint, a final midpoint of 3, 1. Okay, so those are the coordinates of the midpoint that we calculated. Now, every single time you get an answer, you need to go back to your picture and say, does this make sense? Is this actually the midpoint? 3, 1. So from the origin, we go over 3, up 1, and yeah, there's the point that we estimated on the graph. Now, my sketch actually was pretty accurate this time. It's not always going to be perfect. You might be off by a little bit. If it's a half a box off, don't worry about that being incorrect. But if you get the midpoint negative 725, then you'll know you're way off. So it's important to think about that as you look at your picture. So quick check mark, that means we've checked it and we have done a good job. So the next step, and the final step, is to calculate the equation of the right bisector. When we calculate the equation of a line, we need to use the PQ formula for the equation of a line. Y equals M bracket X minus P plus q, where m is our slope and pq are the coordinates of the point on the line. So in this case, we're going to make sure we use the slope that we've calculated, that's the perpendicular slope right here, and the coordinates of the point that's going through the perpendicular bisector, so the midpoint. Those are the ones they're going to use for the equation. So y is equal to m bracket x minus p plus q. Remember the things to note with this equation. When you put your p coordinate, your x coordinate of that point in there, it needs to change sign. So it was a positive 3 over here, and went over here, it became negative 3. But the y coordinate, the positive 1, stays the same sign. Only changes signs when you put it into the brackets because of the negative sign in the formula. So once you are finished substituting your values in, you're going to expand by using the distributive property. So 4/3 x minus, and I'm going to show you this step which you do not need to write down, I'm just going to show you how it works, minus 4/3 times 3, okay, or you can say plus 4/3 times negative 3, it's the same thing. I'm going to show you how you multiply the fraction by the whole number. This 3 is the same as 3 over 1. So it's a negative 3 over 1 times 4 over 3. When you're multiplying fractions, you want to make sure that you reduce. So 3 and 3 down here are both divisible by 3. So if we divide by 3, we get a 1 and a negative 1 at the top. Then we're going to multiply the top times the top, which is negative 4. Bottom times the bottom will just give us 1, so you don't need to write that down. So our next line would be y equals 4/3 x minus 4 plus 1. So y equals 4/3 x minus 3, and that's our final equation of the line. Now how do we check that on the graph? We already know the slope is correct, but we're going to check the y-intercept. This should be where it crosses the y-axis. So we're going to check that on our graph to make sure that it is the right number. So looking at our line, this is our right or perpendicular bisector. We're checking to see if the y-intercept that we calculated was correct. We said it's supposed to cross the y-axis at negative 3. So here's the y-axis, and we're following it down with our eyes, and negative 3 is the spot where it crosses. This y-intercept seems to be correct. That right there is the y-intercept, and it's negative 3. So we know we've done a good job when we calculated our equation of a right bisector. The second thing I wanted to go over with you today was just a brief review of the Pythagorean theorem. Now I'm sure that you remember it from grade 9, but I wanted to briefly just remind you of a couple quick things. When you're looking at using the Pythagorean theorem, you're using it with a right angle triangle only. So it's got to have a 90-degree angle, and you're remembering that the C side in your formula is the longest side, or the hypotenuse. So the side in your triangle that's across from the right angle is called the hypotenuse, and it is the one that they're naming C in your formula. So c squared equals a squared plus b squared. That basically means that if you were to make a square of the two smaller sides and calculate the area of that square, and you'd add up that area squared with the other small side squared, those two areas are the same as this largest side squared. So that's what the formula means. There's a demonstration I'll show you in class with water and a little triangle that spins around that demonstrates that concept. When you're using the Pythagorean theorem, the important thing to remember is what you do depends on which side you're trying to find. So if you're trying to find the hypotenuse, then you're going to square the other two sides and add them. So the hypotenuse squared is equal to the other two sides squared and added. Now squared does not mean times 2. Don't forget, squared means times itself, right? So if you're calculating a number squared, that means times itself. For example, 3 squared means 3 times 3, which is 9, not 6, right? So make sure that you're squaring properly. If you're finding the hypotenuse, that's what you're going to do. You're going to add the other two sides up when you square them. If you're finding a smaller side or a shorter side, find a shorter side, then you're going to need to subtract. The side that you're trying to find squared would be equal to the hypotenuse squared minus the other one squared. And that's the equivalent of your a squared equals c squared minus b squared that you looked at in grade 9. So just remember, if you're finding the hypotenuse, you're going to square them and add them, but if you're finding a shorter side, then it's going to be hypotenuse squared minus the other side squared. So a couple quick examples we'll do on this page together, and then I'll have you finish up the rest of them on your own at home. Let's take a quick look at just the first line of our solution in A and B. So when you're looking at the right angle triangle, you want to first identify the hypotenuse. In this case, it's this side right there. That's the longest side, and it's across from the right angle. So the hypotenuse is the empty side, is what we're trying to find. We can call it X or C or H or whatever letter you'd like. Since we're finding the hypotenuse, we're going to write down hypotenuse squared is equal to, we're going to take the other two sides, and we're going to square them and add them together. So we're going to go 10 squared plus 6 squared. So in that question, we're going to be adding because we're finding the hypotenuse. In a question such as B, this is not the hypotenuse. This empty blank side here is the smaller side in the triangle. The hypotenuse is across from the right angle right there. That's the hypotenuse, just like this was the hypotenuse in the first question. So we're not finding the hypotenuse, we already have it. Because of that, we're going to be subtracting. So x squared would be equal to 12 squared minus 7 squared. The hypotenuse goes first, and the smaller side goes last. Now I scroll down to the bottom of the page because I wanted to show you an example of a full solution, just to show you how to show your form properly. So we'll use 1a that we began. That example said x squared was equal to 10 squared plus 6 squared. So show that first step, please, as an initial equation, and then I would like you to show your answers of each of the squares. So x squared is equal to 100 plus 36. Make sure you multiply it by itself, not by 2. The next step, you can choose one of two steps. X squared would be equal to 136 in this case, or x would be equal to the square root of 136. Please make sure you never ever do this. X squared equals the square root of 136, because that's not the same thing. The squared and the square root contradict each other. You cannot put them both in one line of the equation. Either x squared equals 136 or x is equal to the square root of 136. So notice this puzzle sheet's kind of nice because it has the square root steps in there for you. It shows you the second last step and the final step. If you're going to calculate the final step on your calculator, you're going to do square root 136 to get the answer. And there's two different types of calculators out there. Either you'll have to put the square root sign first and then go 136, or you might have to push 136 and then the square root sign. Approximately, you'll get the answer 11.7. Remember the meters sign, your units needs to be in your answer, and the approximately equal to, if the dot is on top of the equal sign, that means you've rounded your answer as opposed to exactly equal to. See how the square root of 144 is exactly equal to 12? But the square root of 136 is approximately equal to 11.7. That means you rounded to the nearest tenth or one decimal place. If it's a word problem question, you're always going to make sure that you give a conclusion. This was just a diagram, so we don't need to worry about giving a conclusion, but you do need to include your units, otherwise you'll lose a half a mark for each answer. So please do the puzzle, the Ellen puzzle, as a review of Pythagorean theorem. Just a little disclaimer, when you have your answer, it might look like it does not make any sense. It's a bunch of letters together. You have to name each letter in your answer. For example, if the answer was B-A-T, I would actually say B-A-T as opposed to bat. You're not spelling a word, you're actually naming each individual letter. So B-A-T. So make sure that you do that when you're trying to find the answer. It's cheesy, it's kind of funny, but it's a good practice of the Pythagorean theorem.